Happy New Year, everyone. This is Volts for January 1st, 2025.
Thermal energy networks are the next big thing. I'm your host, David Roberts. Back in April 2022, I did a podcast on what was, at the time, a somewhat obscure idea: replacing natural gas networks with networks of pipes carrying water that's heated and cooled using the Earth's shallow crust. Rather than each building having a furnace, each would have a heat pump, pulling heat from or dumping heat into the circulating water. One of the most intriguing aspects of the idea is that natural gas companies themselves could manage the transition, becoming heating and cooling companies, thermal energy companies, rather than merely natural gas companies. It would give them an alternative in a decarbonizing world to simply going out of business. Since then, that obscure idea has caught fire. The first operational pilot is up and running in Massachusetts and may be expanded. Dozens of other utilities are contemplating or launching pilots. Dozens of states are considering bills that would echo the one just passed in Massachusetts, which makes it legal for natural gas companies to become thermal companies. Today, this is one of the buzziest ideas in energy, so I am psyched to revisit it. One of my guests on that first pod, the pioneer of this idea, is back today. Zeyneb Magavi was the research director for HEET, a nonprofit working on the transition away from gas. She is now its executive director. My other guest is Eric Bosworth, who manages clean technologies at Eversource Energy, the Massachusetts gas utility that is running a thermal network pilot. We are going to get into all the juicy details. Hop in, let's do this. With no further ado, Zeyneb Magavi, Eric Bosworth, welcome to Volts. Thank you for coming.
Thank you.
Great to be here.
So, Zeyneb, this is, like I said in my intro, a hot idea these days, very buzzy. Everybody in our little world knows about this, but in the unlikely event that there's some listener out there who doesn't know what we're talking about, maybe you could just start by describing in general terms, what is a thermal energy network and how does it work? What are the pieces of it?
Absolutely. It's both a hot idea and a cool idea.
Yes, exactly.
Sorry. Terrible pun. Yeah. It starts with, the ground source heat pump, which a heat pump moves temperature from one place to another. It can move heat in or heat out, so then you get heating or cooling. And of course, your refrigerator is a heat pump. This is a known technology. What we're doing with the thermal energy network is we are putting the most efficient heat pump, which is often called a geothermal heat pump or a ground source heat pump. We're putting that most efficient heat pump in the building for the customer. And then we're having the temperature supply for that heat pump be coming from the street from utility infrastructure. And that infrastructure is your thermal network. And in the cases we're talking about, owned and managed by a thermal utility, aka your gas utility. And then the temperature of that network is managed and balanced by geothermal boreholes and by other thermal resources. So the minute you have that network,
we're going to get into that, but at least the beginning, you're getting the heat from just a series of holes.
Yeah, and it's really, really important to clarify that the word geothermal causes a bit of confusion. A lot of people think about Iceland, and so the thing we're talking about is, just like you said earlier, it's the shallow, everywhere form of geothermal. It's the stored thermal energy in the bedrock under our feet, and it's everywhere. And what we're doing is basically putting a tube down into the bedrock and back up and using it like a radiator.
Right. So just so people can envision it, a normal ground source heat pump is just connected to a series of pipes that run in your yard, basically your yard or whatever. It's just, you dig down, run pipes to dump heat or pick up heat. Mm-hmm. This is like that, except the network of pipes in your yard is, in fact, a giant network of pipes that runs throughout your entire neighborhood. But otherwise, it's just a ground source heat pump.
Yeah.
It's just that the heat network it's drawing from is neighborhood wide rather than just your yard.
And networking the ground source heat pumps is a little bit like networking computers. Yes, it's the same thing, but you also get some new things that happen.
What is the line drawn, and is there a clear line between this and district heating, which, of course, is not a hot new idea.
No.
It's a hot, very old idea. Is there a technical distinction?
Another really good question. And of course, the Romans did district heating, right?
Yeah.
So I actually, there has been so much confusion with the terms thermal energy network, geothermal network, district heating. So I recently published a taxonomy paper to try to clarify. And what I will say, I believe to be the clarifying correct language, is that district energy systems have this generation nomenclature. They go first generation, second generation, third generation, right? And there's this really interesting thing that happens in district energy naming, where you go from a fourth generation district energy to fifth generation, and you get this step change where it goes from a central source to a distributed source. So when you get to that fifth generation, now we're in the zone for this technology. In the typical definitions in the literature, fifth generation is a two-pipe system. It is dramatically different from fourth generation, which, by the way, can have geothermal. So you can have a fourth generation heating district or cooling district that has geothermal, but you're still going to have a central source and central heat pump. When you go to that fifth generation, you're going to decentralize, and you suddenly have both heating and cooling at the same time. And then what we did when we proposed the single pipe is take it one little step further. So it's a subset of fifth generation.
Oh, goodness.
And we took it one little step further where it is more efficient, a little lower infrastructure cost, and it allows for a really straightforward growth model where you can add people on and off, customers on and off, and add loops to each other and kind of go utility scale, a utility growth model.
Right, you can build incrementally.
Right. So for me, the thermal energy network is any of those ambient temperature heating and cooling networks. The ones that have geothermal energy on them are geothermal energy networks. We could shorten that to tens and gens if you wish.
This is a lot to hold in people's heads.
Sorry.
I think maybe the best way to think about it is traditional sort of old school district heating, which has been around for a long time, typically uses a central heating source.
Yeah.
Sometimes that's geothermal, sometimes it could be something else. And then that heat is carried to all the houses through the pipes. So there's a central heater and then a bunch of pipes. What you're doing with this is distributing the heat source. So instead of a single heat source, there's a bunch of boreholes, and you're distributing the heat pump too. Instead of one central heat pump, there's heat pumps in every home.
Yep.
Is that a good way to think about it?
It's beautifully said. I'm going to have to poach from you. Thank you.
Yeah.
And I think one of the really interesting distinctions here and what separates a system like this from previous iterations is it allows for individual customers to heat and cool on their own cadence versus all customers have to be using the same type of energy. So on previous district systems, everybody is heating at the same time because it's single directional. You're sending the heat out. On a system like this, I can have one customer running heating and I can have another customer running air conditioning. And so it's flexible in that everybody doesn't have to be using the same type of energy at the same time.
I see. So you retain this sort of individual control over your thermostat.
And I'm sure Zeyneb would love to talk about the efficiency gains that you get for that. When you have customers doing, simultaneous heating and cooling, those loads will actually cancel out in the pipe. You don't even need the ground. It makes for a very efficient system.
Right. So if you're just taking heat out of water and somebody else is putting heat back into the water, that you could do without even the boreholes, right? You're just sort of like they're balancing each other out. And
in fact, between the time we last talked and now, Xcel Energy, who's the gas and electric provider for Colorado Mesa, that oldest project we know of, they published a calculation that the system COP for that is 5.7 annually.
This is the coefficient of performance for those who don't know what they're, which is just sort of like how many units of heat do you get out per unit of energy put in. And of course, like, I think this is the magic of heat pumps. So I just want to stop and sort of spell this point out. So like for a natural gas furnace, you get less heat out than you put energy in. Almost any fossil fuel is like that. You lose some in the conversion. So its COP is like 0.9 or something like that. The magic of heat pumps is that you get more heat out than you put energy in. That's the spooky thing about heat pumps, which means their COP is over 1. And the COP here is 5.7, which means you're getting 5.7 units of heat out for every unit of energy you put into the system, which I'm assuming, Zeyneb, is the highest efficiency available of any heating system in the world. Is there such a thing as a more efficient heating system than that?
I've been looking, being very obviously quite nerdy. I have heard report of a similar system in Switzerland achieving a 7, but I have not yet actually seen the data. I'm very excited. And I will mention that Colorado Mesa reports a winter coefficient of performance of 8.9.
Oh, geez. So, well, this gets to my next set of questions, because a lot of people, I think, when they hear this, they think, well, if you're putting a ground source heat pump in every home, why not just make them individual installations? Adding all the infrastructure of this pipe network adds a lot of work, adds a lot of capex, adds a lot of money. Do you get so much additional efficiency out of that it makes it worth building that elaborate network?
This is one of the very first questions I asked when looking at this technology, and there's a couple of interesting benefits that you get out of networking the system. The first and most basic is that you can, for lack of a better term, right-size the bore fields for the load. So just speaking in rough numbers here, let's say we had 100 customers and they needed, on average, 1.5 boreholes to support their buildings. Mm-hmm. Well, you're going to end up putting 2 boreholes at every single home. You're not going to drill a half a borehole. So you end up drilling 200 holes to support those 100 homes.
Right.
When you centralize, you may only need to drill 150 because you can size the central bore field for the aggregate load versus every single individual home. You lose a little bit of capacity, for lack of a better term, when you do it that way. That's before you look at the efficiency gains and all of the other benefits from networking the homes together. That's just simply capital cost.
Less digging. Is digging the boreholes, is that like a big chunk of the cost?
It's a pretty large portion. If you look at the overall budget that we spent in Framingham, very high rough breakdown of it is about 30% of our capital budget was drilling the bore fields. Another 30+% was building conversions and retrofits, so actually putting the heat pumps in. And then the remaining third or so was everything else. Pipes in the street, pump house, instrumentation, civil work, you name it.
I would have thought that the retrofits would be a bigger piece. I mean, that's one of the things I trip on when I think about this. It's just like there's so many different kinds of buildings, like retrofitting a building is a pretty bespoke process, sort of unavoidably. I would have thought that would be a bigger portion of the cost. So I don't know if you can put a figure on this, either of you, but like the standard approach here to electrification of heating is just to slap an air source heat pump on each of these individual homes. That's sort of like the easiest way to do it because you don't need a lot of planning that way, right? People can just do it when they're ready to do it. Do we have any idea, like numerically, how much greater the efficiency of a networked neighborhood like this is than a neighborhood full of individual air source heat pumps? Like, do we have that? Is that measured somewhere?
So I'll start by going a little large on that answer. And there was a fabulous piece of research published by Oak Ridge National Labs in December of last year, 1 year ago, that asked that question, what happens? And it was only asking air source to ground source, that distinction. So our default concept is swap out an air source heat pump. Now we say, okay, instead we're going to swap out a ground source heat pump. What happens? And they did the very interesting thing of actually looking at this from an integrated planning perspective and looking at the grid impacts. And they came out with some numbers that were jaw-dropping. including an overall net present value cost savings on the grid for a mass deployment of geothermal heat pumps of, I believe, $1.7 trillion.
We're going to talk about the grid effects later, but is a big chunk of that value the effects on the grid?
That particular number is the grid impacts value, including like 100 parts of that. But in terms of the other aspects outside of the grid aspects, the cost per month, the customer cost for the energy is established lower than for the air source heat pump if you put in a geothermal heat pump. So it is currently lower than the cost of gas to operate in most research and studies and in case examples.
How dense does housing need to be to make this work? I'm just thinking intuitively, like as you get more rural, you have more distance between buildings, that's more piping, et cetera. So we're still, building early pilots. So I'm assuming there's a lot to learn here, but do we have some sense of the required density?
So I'm going to turn it over to Eric, but I will say that really nailing down that threshold is part of what our research team is seeking to do with all the data collection from the demonstration projects now.
I absolutely agree. There is going to be a threshold or a limit where you get rural enough that the economics of running pipes in between the buildings may not make sense. I've done a lot of work lately kind of looking at our service territory and screening areas to try to figure out where are the best places to deploy these, and actually found some interesting things in going through that exercise, which is that even as you get very rural, most rural areas still have a city center. They've got a town hall, they've got a school, they've got a post office, they've got a downtown, for lack of a better term. And these networks can still work in those areas. I mean, the beauty of them is that the energy source is local. So you're not looking around to say, where's the transmission pipeline that I need to tie into, or
right.
Where is my upstream supply? It really is, you can look at a small area and say, yes, we're in a rural community, but the numbers are penciling for this 1 or 2 mile loop in the downtown of this rural area. And, maybe the people in the outskirts have a different solution that fits better for their individual property because they're a mile away from their closest neighbor. But, those are the things I'm thinking through right now to try to figure out where and how I can deploy more of these.
And I just want to add, David, a kind of speculative item to throw out there, that when you are in that rural area with a mile between houses, really rough calculations that we haven't followed up on show if you do have a water system, your water system has enough distance horizontally underground between buildings that it can be your heat and cool.
Yes, I was going to ask, I'm curious how this infrastructure relates to other infrastructure. So first being, if I have a series of natural gas pipes already underneath my neighborhood, can I reuse those pipes? Or if I install one of these systems, am I ripping all of that infrastructure out and adding a new, different set of pipes?
Always a fun question, and a frequent one. I like to emphasize that the types of plastic that we put in for geothermal are the exact same as the type we put in for gas work. It's one of the great benefits about this technology. The challenge with reusing gas pipe, and this is somewhat unique to our region, but we have a lot of old pipe. We've got cast iron in the ground, we've got steel in the ground, we've got all sorts of things in the region. And so finding an area where you had plastic pipe of a relatively new vintage and it was the diameters that we needed, that may be a unicorn. It's going to be very difficult to find that, and especially over a large area, right? You may be able to find one street that has the right diameter pipe that you may be able to reuse. But for our pilot, and kind of how I'm thinking about it going forward, is get the geopipes in and get them going. I mean, you can size them properly, you can get them installed, and maybe not necessarily reusing.
Then do you just leave the natural gas pipes down there?
Yeah, I mean, that's what happens with traditional pipe replacement these days anyways. If you go in and replace, quote unquote, an old cast iron pipe, what you're doing is you're laying a new pipe in the ground and then you're cutting and capping the old pipe. You're not actually yanking it out of the ground.
So we're just accumulating pipes slowly.
This is a new version of the keep it in the ground phrase. It's carbon. I will just comment that there are different regulatory prescriptions for this. So, for example, the first demonstration project in Massachusetts that Eric's referring to, there's actually an expectation and requirement by the regulators that any of the customers at the end of the 2-year period can be made whole and have their old system returned. So this is not a demonstration of removing the gas system at all. There is a next demonstration project where there was explicit permission where appropriate to remove pipe or to move off pipe, not necessarily physically removing it. So just to clarify that there's a lot of regulatory questions with regards to that actual transition and whether the pipe is physically removed, which is a totally different distinction.
Mm-hmm. And what about other infrastructure? Like, as we were talking about the rural areas, like, it's true it's more cost to go between buildings that are a mile apart, but the water system does that. There are water pipes going to all these buildings already.
Yeah.
Can you get dual use out of sewer and water pipes?
So I've been exploring that for years. I actually first tried to convince my water department in front of my house to let me do that. And the physical answer is yes, where you have enough distance, this is technically feasible. The question is, again, regulatory. And of course, our water departments want to maintain a certain temperature range. And so having clear rules and expectations around how and where you can do it and to what load, we are not there yet, but it is a great potential ahead of us. And I would also say that our sewer systems have waste thermal, and that is a really big opportunity we're trying to move forward with a lot of different people across the country. There's some amazing projects, like there's one in Colorado that has an entire thermal energy network running off of waste thermal from the sewer.
Yeah. I mean, just to spell that out, like, sewage is warm. and if you and we're otherwise wasting that heat. And this is one of the cool things I think about the development of this area is just we're starting to think about where is all the heat? Where is all the waste heat around us? And it turns out it's just like everywhere. There's like heat all over the place. Can
I pick up on that, David? Because this is a big thing that I've been thinking about and trying to figure out how to talk about more is this thermal opportunity. That, we're talking today about this thermal network infrastructure, but part of what it's doing is putting thermal energy on the table, and we've kind of been ignoring it.
Yeah.
And it's the missing piece of the puzzle that's going to get us to where we need to go. And
this is why I love hot rocks.
Right. And so there's that stored thermal that we're talking about in the bedrock that has always been there, right? The solar millennia. But there's also what I've started calling anthropogenic thermal. And I think this is a thing that we haven't been talking about. And there's two forms of that. There's that waste thermal we just mentioned, and that's not just sewer, it's our industrial waste heat, another. And then there's this beautiful other thermal that's terribly depressing, and it's the excess thermal energy due to human-caused climate change.
Oh, that heat.
That heat. and it's enormous, right? And I don't know how much you want to go into this, but all of humanity apparently uses about half a zettajoule. And our ocean's absorbing 5 zettajoules a year. Since 1970, over 300 in the bedrock and the oceans and the rivers. And so all this excess thermal energy, we can use it with heat pumps, with thermal networks. We can tap it.
Yeah, that's poetic. There's a some poetic justice to that, or I don't know what the term is.
There is.
So, Eric, this is a question for you. Intuitively, this seems like a pretty short leap for a natural gas company. You're dealing with pipes, you're circulating fluids, you're interacting with customers, you're charging customers monthly rates. Like, a lot of the pieces of this look similar to pieces of what you're already doing. But of course, what do I know about running a natural gas utility? So maybe you could tell us, like, how big of a lateral leap is this?
Well, to be fair, we're on the same page as you because that was essentially the pitch that we made to our regulators back when we asked for permission to do this project. I mean, for a little bit of context here, the state of Massachusetts has set strong goals towards decarbonization, and we as a company are aligning with those goals. And so we asked ourselves, if we're transitioning over to clean and zero carbon offerings for our customers, what does that mean for the gas company, the gas industry, the gas workforce? And to your point, this technology checks a lot of the boxes of what we do day in and day out with our traditional offerings. And so we really made the pitch that we'd be a good candidate for owning and operating a system like this. This is what we do every day. And we looked at the skills required to install and operate a shared network geothermal system like this. And we basically had them all in-house already, save drilling some boreholes. So a great example of this is the mile of pipe and the service lines that we laid down in Framingham to connect all of these customers up. All of that work was actually done by one of our traditional gas contractors. We brought them out on site. We showed them the geothermal pipe, which is the exact same plastic resin that's used with gas pipe work. And we basically, had a one-day training with the pipe vendor that came out and double-checked that the guys knew what they were doing and that the fusion techniques were appropriate. And we were off to the races. We were, trenching in the street just like we would every day with regular work, laying down the geothermal pipe, pulling service lines. And in terms of work streams, that one was by far the one that was done most efficiently and most on budget. It kind of came in right where we knew it would because this is what we do every day. Right.
Pipes are pipes. Since we're talking about it, tell us a little bit more about the pilot than the Framingham pilot. For starters, how big is it? Like, how big of an area are we connecting up with this?
Yeah, so at a high level, we have about a 1 mile loop of pipe. So it's a continuous circuit in a neighborhood of Framingham. To give you an idea on load context, we're talking about 375 tons of peak heating or cooling load. It's pretty well balanced between the two seasons.
Is it all residential?
It's a mix, actually. So what we wanted to do is, first and foremost, we wanted a nice mix and load for efficiency and balancing of the system. But we also wanted a good cross-section of our customer base. We didn't want to just do residential and then have somebody come in and say, yeah, but most of your service territory has commercial and multifamily and all of these other things. So we did our best to capture all of that within this 1 mile loop. And happy to say I think we hit the mark there. We've got about 22 residential homes. We have 5 commercial buildings that range from large, there's a portion of a school connected to the loop, all the way down to a small business cabinet shop. And then the balance of the load is about 108 low-income Framingham Housing Authority apartments. So we've got every customer type. We've got customers that were on gas, oil, electric resistance. We're going to get a lot of good data out of this set.
So you are laying these pipes next to the existing natural gas pipes, and then you're going into all these buildings and pulling out old furnaces and old resistance heaters, replacing them with heat exchangers, with heat pumps, and then you're telling everybody involved at the end of, 2 years, if you don't like this, we'll come restore your original setup? Is that the idea?
Yeah, that was built into the contract, actually. So we tried our best to indemnify our customers to basically say, we're here to gather data, we're doing a pilot, we're confident you're going to love it and it's going to work well, but here is your break in case of emergency clause in your contract if you need it.
Has anyone asked for their original setup back?
No, they have not. And, I'm fairly confident customers will be happy with these systems going through the first winter and then the first summer here as well.
Yeah. Get some AC. I'm curious, if you're a sort of efficiency-minded contractor, when you're switching out systems, you're also going to do some envelope sealing or whatever. There's usually other things involved with this. Is this purely pulling out an old furnace and adding a new one? Is there any additional work being done on these buildings?
Oh, there's a lot of work being done, depending on the building. You mentioned it earlier, but building retrofits are not easy and simple. In some cases, they actually were. I'll give the example of the schools that had rooftop units feeding a distributed air system. Basically, in that case, what we did is we came in with a crane and we pulled the old gas-fired unit off the roof. We dropped the new heat pump in and we piped the water lines to it. We reused the entire building system. But in other cases, we were upgrading main electrical panels, we were running ducting, we were insulating, we were air sealing, we remediated a bit of knob and tube wire in one case. So there were certainly some skeletons in the closet on these.
But you got everybody, there were no deal breakers. Like everybody in the area is on the system.
Everybody who wanted to participate and signed a customer contract, we didn't turn anyone away. I'll put it that way. There were some more challenging conversions for sure. But again, we wanted to demonstrate what it takes to wholesale convert neighborhoods.
The big question here is about costs and who's paying for what. So my first question is, who paid for the pilot? Because I'm guessing the customers here are not paying to have these things done. So who's paying for the pilot? And then if this shifts from pilot to whatever real thing, then who pays?
Yeah.
To answer your first question, the pilot was funded through a gas rate case, actually. So it is being recovered via our gas rates as a demonstration pilot.
The whole Eversource rate base is sharing the cost here?
The whole NSTAR gas rate base, yes.
Ah, got it.
All of the customers are in some tiny part contributing, yes. And then they have a participation monthly fee, but it is ratepayer based. And that was the very first permissioning, that was part of the discussion, was the value of the demonstration project to the gas ratepayer base.
Right. And so is the idea that if you continue with this, keep doing this, that is going to be the standard? Like all the costs are going to be shared across the entire rate base throughout the process?
So to me, there is some beauty in this, in that if we proceed with moving buildings off of fossil fuel heating in Massachusetts, as is our climate mandate, we will have a shrinking ratepayer base with unfortunate spiking costs, which would be a really challenging equity situation and affordability situation. It's that problem of the last grandmother holding the bill for...
Yeah, yes, this is, of course, a problem anywhere you want to phase out gas, is that you need to do it chunkily, right? It can't just be individual consumer decisions.
There's chunkily, but this approach allows for stabilization of that ratepayer base, because as you are shrinking streets with gas, you're increasing streets with geo. And if the decision is made to leave it as a merged ratepayer base, then in the end, when you have fewer gas customers and more geo customers, those geo customers are stabilizing the gas customers.
Are they paying as much as they were when they were gas customers? Like presumably the whole promise of this is hyper efficiency. Like theoretically they should be paying less, right?
So in the case of the pilot, the short answer is yes. We do have a very small nominal fee that we're charging as kind of a customer service fee for the geothermal system. But to give you an idea, we're talking like $9 a month for a residential customer. The whole point of the fee was to establish a billing relationship with customers that may have been on oil previously and not received a bill from Eversource, so that they get something that says, Eversource geothermal on it, and we establish that relationship. From an operating standpoint, we're obviously just starting to get data on a heating season here as we get some colder months. So we can't say for sure with hard data, but we did look at like a 2-year previous consumption average annual usage on these customers. Mm-hmm. And we ballparked what we thought they would use on geothermal for electricity. And pretty much across the board, there were savings for these customers. So, from an operating standpoint, it looks like the electricity that is needed to run these ground source heat pumps is cheaper than their previous electricity and gas bill combined.
Mm-hmm. And if you undershot, it's fairly easy to just add more boreholes, right? I'm just incrementally add boreholes, I'm guessing.
My prediction is that, as is often true with utilities generally, they were cautious, and there's going to be plenty of room for the additional customers that are now asking to join.
Well, this gets to a big question I had for you, Eric, which is, what is I guess, I don't know if customer acquisition is even really the right word in this context, but like, you have to go to an area and talk everyone in the area into doing this, basically, right? Like, So what is that process? Like, if there are holdouts who just say no, can you just build around them?
So in terms of the pilot, customer acquisition is probably a totally accurate phrase here. And full transparency, we actually retrained and reutilized folks internally that were traditionally on the gas sales team. So these were people that were going out and going door to door on gas expansion projects and were now trained to sell geothermal in the neighborhood. And what we did is we took the same approach. We went out into the community. We generated marketing materials, informational materials. We had fact sheets and all kinds of information. And then we approached the customers and said, hey, we're doing this pilot. Here's what we're doing and why. Do you have any questions about geothermal in general? Do you have any questions about what we're doing? And we took the time to sit down and speak with them. And honestly, the results were overwhelmingly positive. In the neighborhood, on the loop route, I think we had about an 80% positive rate on customer acquisition. And of those that we didn't get to sign up, the vast majority were because we weren't able to talk to them. We just never managed to connect with the customer. We had one customer who had just redone their HVAC system that year and basically said, I'm not going through that again. I just tore up my house. I can't. But by and large, they were all very positive.
Well, the reason I ask is that obviously the goal here, the larger goal, is to shut off gas, right? The larger goal is to shut off the gas system. And if you have a single customer using gas, you have to have your whole gas system running. So there is kind of you ultimately are going to have some ability to pressure people, right?
I'll jump in and speak to that, because that's not what the demonstration project in Framingham is testing. And it is, of course, a really interesting question as we face a kind of utility evolution. And of course, there's a lot of conversation around customer choice, and customers do have a choice, but they don't have a choice among multiple different energies from one utility. They have a choice with one utility of whether to hook up or to not hook up. Right?
Yep.
Your electric utility doesn't say, well, here's all the forms of energy. We have radiant, we have, and so that question of how we have regulation and laws around it is beginning to be talked about across the country. And the question of how the obligation to serve, and however it's expressed either in statute or in regulation in each state, whether that can be expanded to include this thermal service, so the obligation to serve a customer is met by providing this more modern thermal. So one state made a first go at that, and then Massachusetts has just also, in its most recent climate bill, signed by the governor last week, has explicitly turned over some clarification of that obligation to serve to the Department of Public Utilities. I think this is a conversation that is very live and hot. How are we going to both ensure that the equity aspects of course, serving every customer on the infrastructure be met also with this evolution of the kind of aggregated good of a single infrastructure?
But I guess I just come back to if Eversource shows up at my door and says, we're not a gas utility anymore, we're now a hot water utility, we'll hook you up with hot water or you're on your own. Is that the idea?
That is not resolved yet. All I can tell you, so that is a conversation that needs to happen over time with every stakeholder involved. And I will tell you that I have a vision in my head of something happening a little bit like what we see today with new gas pipe, where the door hangers come out, and a year ahead of time they let you know, well, we're going to be, you've got a leaky pipe, and we're going to be upgrading your infrastructure in X month of X year. And here are the things we need to do. We need to get into your basement. We need to, and I think some version of that with a time delay, with time for the customers to make decisions, to engage, to be supported, with provision of all, necessary elements, will happen with this upgrade, where you'll get a notification that the street is switching to modern thermal to meet state mandates and deliver a safer, more affordable energy. And here are the steps, and here's what's going to happen, and we're going to support you. And you can choose not to. You can get off of our utility. That's always your choice.
But then there will be no gas utility that you can then resort to, right? Gas will not be among your choices.
You can choose at that point to get a propane tank or other tank.
Right. You can buy your own gas.
So again, this is me speculating, not a regulator or a state or a utility.
Eric, I mean, you're in the utility. You obviously have to be sensitive about this, but what is the utility thinking about this issue?
Absolutely. And one thing I'd like to point out, Zeyneb did just mention, propane or other delivered fuels. One interesting thing that I've been thinking about is you kind of not avoid, but you can spend some time solving this problem here if you're deploying these systems in areas that don't have any existing utility service, right? We still have something on the order of, and Zeyneb, correct me if I'm wrong, I think it's about 40% of the customers here in Massachusetts are still on delivered fuels. They're on heating oil and propane.
Oh, wow.
And this is entire communities in some cases. This isn't just one-off customers.
That's unusual, though. That's mostly the Northeast, right, where that is still...
I don't think it's that unusual.
Huh.
71 towns, I believe, in Massachusetts don't have gas.
Connecticut's similar.
I mean, unusual on a national level. Like, it's the Northeast of the country where that is mostly still the case, as I understand it. But I could be wrong about that.
I'm not sure. I'd have to look up the numbers, but I think it's really the denser, more urban areas that have gas infrastructure.
And so is the idea, Eric, that you would always, you don't want to show up at a customer's door and say, hey, we're switching from gas to hot water. Now you have to personally purchase a heat pump. So is the idea that the cost of putting heat pumps in, say you're going to expand this to a new neighborhood, you're going and knocking on doors, you tell them that it's going to happen, is the idea that the entire rate base will share the cost of all these new heat pumps? It's not the individual customers who will have to pay for this, right? Because otherwise, you're just going to get a bunch of customers saying no, right? If they have to pay for it.
Yeah, and I think it's a question that we're trying to answer with the data from Framingham, honestly. The way we framed the pilot initially was we're going to pay for absolutely everything because we want to make it as easy as possible for customers to say yes and get the data. Going forward, whether we're doing some program like an expansion on Mass Save, which is our energy efficiency program here in Massachusetts, to focus on the building side, or there's some other financial structure, for lack of a better term, that's what we're trying to work out with the state, with our regulators, with our stakeholders, because I don't think we have the data right now to be able to clearly answer that.
I will just add to that it's my opinion that the building transition will not happen if the entire cost burden of the building transition is borne upfront by building owners. And if it does,
yes, I think that's fair to say.
If it does, it will be massively inequitable.
Yeah.
And so really understanding how to appropriately finance that building transition, having the utility in the mix in this case, I think that's a really interesting open question. We're trying a lot of different models across the country.
Well, has anyone pitched that this ought to be part of state taxes, that it ought to be broadened beyond the rate base to taxpayers that should pick up? Because, theoretically, they're all taxpayers are benefiting.
I think that conversation has certainly been had. I don't think it's been directly filed, but one very wonky idea is a question of using securitization to drop the cost of this infrastructure and use this cost, quote unquote, savings to cover low-income building transitions.
Interesting. Yeah, it seems like there's a lot of room for financial innovation.
Yeah. And
there are a lot of unanswered questions.
And I think one of the pieces that I think is coming to light as we begin to do actual decarbonization is that it's not just the heat pump and the weatherization, which we kind of understand what we need to do and understand how we're going to, the options for financing. It's also, particularly in our lovely Northeast, it is the 100 years of delayed maintenance that we hit in a number of the buildings.
Yeah.
And it's that mold and asbestos and code violations.
If you could, the utility can come say, we'll pay for the heat pump, but then where does the utility's obligation end? Like, does they also do the envelope? Do they also, you know what I mean? Like there's each of these old buildings is a sinkhole of money potentially.
And just to clarify here, this isn't a problem unique to geothermal,
No.
Regardless of if the utility is involved or not. If you want to mass deploy air source heat pumps, you still have to tackle the building envelope.
True.
I mean, it's a problem no matter what technology platform you choose.
Yeah. Dana, this is a question, and no offense to you, Eric, on this question, but is there any particular, like cities also know how to lay pipes and distribute water? They municipal, so there's no reason that this has to be done by natural gas utilities, right? And I mean, even wondering, is there any particular reason other than the sort of political economy reasons of like it's going to reduce their opposition, obviously, if they have something to do, but like on the merits, is there a reason that we want natural gas companies to be in charge of this, or should we be more agnostic?
Well, I will say that I started out quite agnostic and approached a lot of municipalities in addition to the gas utilities and others. Mm-hmm. I mean, the technology will work no matter who installs it. I think the pieces that are critical to that question, it's not just that political economy of, transforming a gas utility into a driver of decarbonization, a deliverer of decarbonization, but also it's that really critical conversation about workforce and skill sets.
Yes, I meant to ask that earlier.
Yeah. So there's that workforce piece, which we can open up. There's also like a kind of skill sets in the energy system question. There's just a huge amount of policy experts on the electric grid and quite a significantly fewer on the gas grid. And yet some of the load management, seasonal storage, and other aspects that the gas system provides our overall energy system actually really match and mirror this thermal system. And I see more synergy than even just the workforce in the transformation of gas to geo. But in a kind of practical, hard reality way, I will say that our municipalities, though many are interested and we are engaged with a number, are often resource strapped with a lot of other challenges in our world.
Yes.
And the sheer incentive of an existing thermal utility with existing relationships from regulators and so on is another advantage.
Eric, and you have the workforce for this? Like I'm trying to figure out if there are any novel kinds of workers required here. Like you have pipe people, and I don't know, is there something about heat pumps that requires some new training? Like what is the workforce situation? Hey there, everybody. Don't worry, I'm not going to tell you about a new mattress or push a credit card on you. This isn't an ad. There are no ads on Volts. It is supported entirely by listeners like you. If you'll indulge me for a second, I'd like to ask for your support. I started Volts because we're all surrounded by depressing news about climate change and misinformation about clean energy, and it's never been more important to share the stories of the real people on the ground doing the real work of transition and all the ingenuity and courage and public spirit they are bringing to it. People are hungry to hear these stories, to learn from and find inspiration in them. I've heard from people who changed majors or careers after hearing episodes of Volts, people using it in classrooms and community groups, even state legislators who have passed bills inspired by specific episodes. Sharing these stories matters. It makes a difference. If you have found value in it and want to help me continue doing it, I hope you will join the community of paid subscribers at volts.wtf. It's about the cost of a cup of coffee a month. If you don't like subscriptions, you can make a one-time contribution, leave a review on Apple or Spotify, or just tell a friend about Volts. I am grateful for any and all support. If you're already a paid subscriber, thank you. And now, back to the show. I don't know, is there something about heat pumps that requires some new training? Like what is the workforce situation?
So you're absolutely correct from a pipe perspective. Just to give you an idea, we put something like 100 miles of plastic pipe down a year right now. But that being said, drilling is definitely a novel skill set that the utility does not undertake day to day.
Right.
I had the fortunate privilege of, my first career was actually upstream oil and gas. So I came into this with quite a bit of experience. And I kind of like to say I'm that transition story moving from traditional fossil fuel work to clean energy now.
Yeah, step by step.
It's not something that exists generally within the utility. And so drilling workforce is one. And then even the building work, not to harp too much on it, but we're generally not in customers' homes as a matter of day-to-day work. We have a clear demarcation point with our meter or our valves or whatever it is, and we say anything downstream is the customer responsibility. And so that was a bit of a unique one as well, dealing with HVAC contractors and electricians and being in customers' homes.
The people who are involved in that feel a lot of sympathy for you right now. I have a feeling that's a whole briar patch, as they say. Are you, and this is also, it's probably too early to know this either. Zeyneb, maybe you could chip in here, but I'm wondering if there are economies of scale here. Like, is this going to get cheaper as we do it more?
Yes.
Or is it, in some sense, bespoke to individual buildings and communities? There's a certain, in a sense, every building and community is unique. So how sort of modular and replicable is this? Are we going to get cost declines over time?
I'm so excited you asked that. And and I think we can point to Colorado Mesa for some initial data. I always like to go to the data. And they showed that there was an incredible drop in cost per ton between the first loop and the second loop attached.
And that's just learning by doing? That's just
it's
figuring out how to...
that, actually. There's a learning curve, yes, but there's something inherent to the infrastructure where the first one has the larger pump station, and then the second one is actually in part thermally stabilized by the first. And that efficiency of the aggregated load calculation increases as you increase the number of buildings.
So the next increment is going to be cheaper.
We've ballparked it.
We were lucky enough to design a second loop through a Department of Energy grant for the city of Framingham's loop.
Yeah.
When you say a second loop, you mean not going to the same buildings, a new group of buildings.
A growth model.
A new block of buildings. Yeah.
Yeah, and just very high level, rough orders of magnitude. We're going to presumably about double the size and capacity of our system. So we'll double the load on it at about half the cost of the original.
Interesting.
So yeah, we're looking at pretty significant cost reductions. And to Zeyneb's point, a lot of it is around the fixed infrastructure that we've already got. So we have a pump house, we have instrumentation, we have controls, all of that is already in place. But also we're going to have to do less drilling for those customers because we've presumably got a little bit of spare capacity on the main loop, and we have that thermal stabilization that Zeyneb mentioned where, we're going to swing through the peaks a little bit easier with more mass in the system and more customers connected to it.
Right. It's that point you made about 1.5 boreholes, right? Just expanded to large numbers. Like you need fewer boreholes as you have more customers.
It's actually even more than that. To get a wee bit nerdy for a second, it's kind of cool. So it's not just the boreholes. Remember, we have three parts. We have the thermal infrastructure loop in the street. Then we have the thermal resources, which in this case are boreholes. And what we're seeing and understanding is that the thermal loop itself is like a moving thermal energy storage mechanism.
Yeah, sure.
And so you've got this thermal inertia on that loop. And so as you grow the system and you get the increased number of customers, you're actually also increasing your thermal storage on the system. That's increasingly stabilizing and moving the time boundary of the load out.
So you need less incremental new heat source for each new customer. Is there a horizon point there where you no longer need to do any boreholes at all? Like, I don't know how many.
I doubt that.
I don't know how big these things could get.
I doubt there's a horizon point, but there is, interestingly, we can add marginal customers without drilling for the most part. And what that allows us to do is we can actually decouple the drilling and the capacity addition with the load addition. What I mean is I may drill 20 or 30 boreholes in a summer to add capacity to the system, but I can be adding customers all through the year and I don't have to wait for those boreholes to be drilled. I can do them asynchronously.
This is interesting. So, Zeyneb, we're running a little bit short on time here, but I wanted you or you and Eric to talk about just where this is popping up outside of Massachusetts. Like, last time we talked in 2022, I think the Framingham pilot was mostly a gleam in your eyes, and that was it. That was it. That was all that was going on. Now there's all kinds of things going on. So give us a little bit of an overview of. There's a bunch more utilities investigating this. There's a bunch more states. Let's start there. What is a state law? What do you want from a state legislation?
Well, that essential permissioning that allows a gas utility and or other utilities to build this infrastructure and sell thermal energy.
And that requires legislation everywhere.
Not necessarily. We do everything on a state-by-state basis in this country, as you know.
Yes, so fun in energy.
There are projects that are in states where it's not as much of a concern. But at the moment, we have 8 states that have passed this gas to geo law permissioning.
Interesting.
With some of them having other elements, of course, and those are Massachusetts, New York, Vermont, Colorado, Minnesota, Washington State, California, Maryland. I hope I didn't miss any.
And this is all just saying, you natural gas utility, if you so desire, can become a thermal utility legally. That's just what the law says.
To be clear, each law is its own.
Right.
And so,
or is this you have to become a thermal utility?
For example, some of them mandate demonstration projects.
Right.
Some of them do not. So there's every state is a petri dish, right? There are 5 more filing this year that I know of, and there's a whole advocacy network we do together with allies. And there's so many great organizations and people across the country now involved in driving this forward where they are. And I just can't even say enough about that. There are 20.
There's no geography where this couldn't work, right?
Oh.
I mean, this is more or less universal, right? I mean, with enough density.
So it can absolutely work anywhere. And what I would say is the question is the payback period. And so where you have very small heating and cooling loads, your payback period is longer, and it may not be the wisest economic choice, but it will work, sure.
Right. You might be better off with an Eversource heat pump in a very mild climate.
Yeah, and it's not that it won't work. Yes, this will work anywhere. It's the everywhere geothermal, but it doesn't necessarily make a wise infrastructure investment everywhere.
Right. Is it safe to say that the financials will look better in colder climates, in more extreme climates? Is that fair to say?
And hotter climates. So more extreme and or very balanced are going to generally look better. And I think we're going to get a lot more data coming out with potential studies soon. But I just want to add that there are 20 pilots filed with commissions for utilities to build, many more that are outside of that. And there are 29 gas utilities meeting regularly in an amazing coalition to consider a geothermal future.
And this is geographically spread all over the place, or is this mostly Northeast?
No. It's really important to realize that the geothermal heat pump, one of the kind of center points of that world is Oklahoma, and actually they've got an amazing pilot moving forward. So it is all over the country. This isn't everywhere. You know, in Framingham, the spray paint on the street for this infrastructure is purple. And I think that's awfully symbolic because this technology is all over the country. A huge portion of the industry, including a lot of the geothermal heat pump manufacturers, are in the Midwest and the West. And it is really a nonpartisan technology. It is. We apparently can agree on this.
Well, my eyebrow goes up. Let me ask this. If I was in a state and a utility that did not care about climate change at all, and did not care particularly about pollution, only cared about money, cheapest possible system, would I be interested in a system like this if I lived in a place like that?
Absolutely. That's the beauty of it, is we talk to groups and people and utilities all the time that have a mindset that isn't focused on climate, that are putting first things like, profitability, affordability, safety, resilience, reliability, energy security. Energy security is huge.
Maybe we should have said this. It's almost too obvious to point out, but it's worth saying. If your heat source is the shallow Earth, it's always there. It's always the same temperature. There's no supply chain that can be cut off. There's no other country that can cut off your supply. You're not exporting money from your community to get it. So it is the most predictable and steady source of energy you can find.
And this is why Eric and I hosted a lovely tour from a delegation from Ukraine. Yes.
Yeah, I guess those same advantages are true anywhere, really. Anybody who's stuck exporting money for fuel, for heat, it's a big cherry.
And there are some places in the world where they are heavily reliant on energy imports specifically. And so the value proposition of having localized energy and security, we may not think about it as much here in the States because we've got local energy production, but it can be massively important for other places in the world.
We're seeing a lot of interest from around the world. And the IFC, there's a video that actually played at COP29 with the Financial Times made. I think one of the statements was, we've awakened a sleeping giant, and they had video of the Framingham project, but really looking at the kind of sustainable development goals aspects of this decarbonization pathway.
Right. And this is also something that's maybe too obvious to point out, but I'm going to point it out anyway. If you proceed on a consumer choice basis, as you noted earlier, you're going to start with the wealthiest people and work backwards, and you're going to be stranding the poorest people with the system costs of the system that's left over. So doing this on a neighborhood by neighborhood, community by community way is the only way you can get your arms around the equity aspects of this. That's the only way you can control the equity aspects of this.
Yeah, very well said. And that's been central to HEET's effort from the beginning, is we actually want to see it deployed first in the most vulnerable communities so that they get the safest, most affordable, best energy earliest. And I think that's where that question of who owns it, the gas utility doing that adds that stabilization of the ratepayer base.
Yeah, and the stabilization of rates themselves, just like, this is something also that like poor people have to think about more than probably most of the people listening to this pod. It was just fluctuations in energy costs. Because natural gas is always, the price of natural gas is always changing. Those are unpredictable and can be quite devastating to household budgets. And this is like, how much your heat and cooling is going to cost this year, next year, 10 years from now. It's going to be the same forever. That's like just that stability, never mind the level, just the stability itself is a huge advantage.
And that's the kind of conversation that I hear over and over again. There are these amazing leaders in this industry who built the geothermal heat pump industry. They're all over the country. Like I mentioned, quite a few in Oklahoma, and one friend from Utah, these are the conversations I hear over and over that have been spreading the kind of pleasure and joy of this technology. It's about those elements. And it's only recently in these conversations in the Northeast that it's become additionally connected to the effort to decarbonize in a different way. I think it's a multi-solving technology that's kind of practical. And that's why I said, it is something everyone can get behind. It, maybe not all for the same reasons, but that's kind of what I hope for the country, right?
Two final questions. I always lie when I say that, but I mean it this time. Two final questions. One is, just say a few things, the pilot here, the heat source is geothermal boreholes, which are what, like 1,000 feet, something like that? How
600 to 700, depending on the hole. We, not to go down the rabbit hole, sorry, the pun.
not the borehole.
Some of them are deviated, which means we drilled them at an angle. Those are about 700 feet total depth. A traditional vertical borehole on our system is 600.
Interesting. So that's the source of heat here, and in most cases, but there are, as you mentioned in passing, Zeyneb, you could have the same distribution system hooked up to a different heat source.
Yep.
So maybe just say a little bit about the variety, like what kinds of things are people using as heat sources for these systems, and could people theoretically use?
Oh my goodness. There's a couple of wonderful products out there for capturing waste thermal, like we talked about with sewage. But there's also a lot of wonderful opportunities to capture thermal energy from our bodies of water, aquifers, lakes, rivers, the sea. Mm-hmm. There's some titanium seawater heat pumps out there that have me really excited. I think we can maybe make the lobsters happier in Boston Harbor while heating part of Boston.
Oh, taking some of the heat out of the harbor?
Yeah, it's restoration effort.
And putting it into the houses? That's quite clever.
Yeah. And there's also really interesting, clever things once you begin to play with thermal energy and see thermal energy. Like Colorado Mesa, for example, creates cooling capacity in the summer by dumping heat at night into their irrigation system. It's the most cost-effective cooling I've ever seen.
Huh.
There's places where there's snow melt as a way to do the same thing. Like, there's a lot of fun opportunities.
You can shift heat from one place to another. What about like just industrial? Has anybody hooked one of these systems up to like a data center or a factory of some sort? Or
big conversation. There's some projects in Europe. I think one of them I was most recently hearing about was looking at a milk pasteurization plant. We've looked at a brewery in Colorado as a fabulous thermal source. There's tons of opportunity for industrial waste heat capture. And I would say data centers is an obvious and exciting one. I know there's some geothermal greenhouses in a bunch of different ways all over the world, but having greenhouses off a data center is another one.
So theoretically, any building you hook up to a network like this is going to receive the benefits, but is also, some of them can be contributors, right? Could be net contributors of heat because of processes in the building.
Yeah. So the buildings themselves are prosumers. They're both users and producers of thermal energy. And this is why you need a thermal utility. And in essence, by building this infrastructure, you've built a thermal market.
Yeah, I really think that, like you said, like we've spent so long not thinking much about heat just because, fossil fuels are cheap. This is an area where once you start looking, right, you just find it all over the place. You find heat or cooling, spare heat or cooling all over the place. And it's just a matter of grabbing it. I think once you set up this network, people are going to then start thinking, oh, like what else can we attach to this, right? Anything that produces or uses heat.
And to be clear, it wasn't within the scope of our pilot, but I'm actively thinking about it a few years down the line when we're out of the pilot period. What resources do I have nearby that I can tie into this network and potentially, not drill more boreholes, but add load and expand it?
Right, just balance it out.
Yep.
Well, I meant to ask, are you green lighted to do this beyond the pilot phase, or is that decision TBD?
I will say that we do have the legislative authority to do it as a utility now, as Zeyneb pointed out. Mm-hmm. We are still a regulated utility. So in order to spend money, we have that review by our regulators to go in front of them and get approval to do it. But, no real legal hurdles to additional projects.
So all you need is permission from your Public Utility Commission in Massachusetts.
Yeah, and I'm going to comment that we had a regulatory ruling on our Future of Gas docket that came out with a bit of a name change to a Beyond Gas framework here in Massachusetts. And one of the two top paths forward that the commission flagged as of interest was geothermal networks. There's a lot of interest and excitement in the state. So not only do they have legislative permission and absolutely need regulatory permission, but there's a lot of excitement and obvious enthusiasm for this. And our commission issued the first ever geothermal network pipeline safety regulations.
Yeah. I didn't really ask much about safety because, like, what do you get, a hot water leak? Like, it seems like the risks here are somewhat limited.
Not even hot water. To give you an idea,
warm water leak.
My expected temperature range is between about 40 degrees and 70 degrees. So we're at relatively reasonable temperatures. I mean, we have about 20 to 30 PSI on the system. It's not even high pressure. I mean, really, this is about service quality for the most part, making sure the system is on and running efficiently and that it doesn't go down.
But you're pretty certain it's not going to, say, explode and take out an entire city block like the natural gas system did to Seattle a few years ago.
The worst case scenario for me is my pumps shut off and my fluid stops moving, and we get out there and figure out how and why to put it back on.
Right. Okay, final question, which is what one I've been meaning to get to, which is, let's talk a little bit about the grid impacts of this. So one worry when you're talking about electrifying is in northern latitudes, in cold places, right now, winter heating, which is a huge amount of energy, is being done mostly with oil and natural gas. If you do that with electricity instead, then you risk creating this massive, massive spike of electricity use during the winter, which would be entirely new to those areas. And then you're having to update your grid, et cetera, et cetera. So that I think the part of the appeal here is that a networked set of ground source heat pumps is going to consume much less electricity than the commensurate number of air source heat pumps. And thus you are, to some extent, forestalling that grid crisis. Is that a decent summary, Zeyneb?
I think so. Absolutely. I think that the numbers that we're seeing in research are just really quite jaw-dropping.
Yeah, what is the savings when you move from air source, a bunch of air source heat pumps to a bunch of ground source heat pumps that are linked up? Like, what is the scale of the savings?
So we don't actually have that number, but Eric can speak for the one project.
Yeah. In terms of energy savings, we're expecting peak and annual load to be about half of what it would be on air source heat pumps with the same customers.
Interesting. So that's just like half less grid infrastructure you're going to have to build to electrify Massachusetts.
Yeah. So that's that project. And I just want to be really careful about what we say and claim. So the numbers I do have are for individual ground source heat pumps, which are, as we've kind of discussed, these networked are even more efficient. So this is a low ball estimate, but for the country, it would be a 38% reduction in transmission lines, over 1.5, close to $1.7 trillion of savings, a 12% reduction in wholesale electricity cost, a 13% reduction in generation. In Massachusetts, a 34% reduction in load in 2050.
Good grief.
Yeah.
So this just makes electrification easier.
Yes.
Among the other things it does, it is a way of electrifying heating with low electricity.
Yeah, exactly.
And could actually, kind of maybe looping back a little bit to the why the utility question, could be used strategically in areas where we are constrained, right? We're looking at this actively as a potential for maybe we don't have the grid capacity to roll out air source heat pumps in this town. What if we did geo and then didn't have to make any improvements?
So you could target these things as kind of grid congestion easing tools.
Yep.
A tactical thermal transition.
And not to totally nerd out, but they can be used for demand response as well, for lack of a better term. You can precondition the loop prior to a peak and ease it even further.
Oh.
Yep.
Yeah.
Lots of rabbit holes to go down.
I'm just processing that. So you can, like, if the grid says, we're going to be especially congested at 4 p.m., you just dump a little additional heat into the network prior to then. So then your heat pumps are just doing a little bit less work at that hour.
And then you can use the thermal inertia of the system to coast, which Colorado Mesa, there used to be a benefit to load shedding, and they had a demand shed button right on their control system where they would just hit it, coast for a few hours, and then come back online, and no customer ever experienced a difference.
Right. So you don't need steady, always on heat application here. You can cut the heat on and off based on grid needs.
You can speed your pumps up and slow them down. So we'll actually, on our loop, have the ability to speed our pumps up, precondition the loop, and then slow them way down to go through a peak and respond to that load, for lack of a better term.
Oh, interesting. So it's lower electricity requirements and it's more controllable electricity.
And also, as soon as you get to a certain scale with a thermal network, if you've grown to a utility scale, it becomes cost effective to do larger scale thermal storage systems. Not unlike the gas utilities currently have a whole network of seasonal gas storage, more intermittent thermal storage can begin to address our load peak in the winter in a kind of resilient way, in a cost-effective way.
So spell that out a little bit. So that would mean like a network like this would be connected to, I don't know, a big lake, and it would just store a bunch of heat in the lake that it could use in the winter?
That's one way. In Europe, there's quite a few, they're calling them A-TES and B-TES and aquifer thermal energy storage, borehole thermal energy storage. There are phase change thermal energy storage tanks, like a molten salt battery, for example. There's a whole bunch of possible technologies that can potentially store thermal energy for different ranges of time. Possibly we have some unused wind energy on the grid at night. We dump it into a large thermal storage system, and then we use it seasonally to cover our peaks on the thermal grid.
And cheap, too, to store heat relative to storing electricity. You can use it with such fancy materials as water or bricks. So this is then, to summarize here, since we've gone over, this is cheaper for customers. I'm guessing, if you believe in heat pumps, more comfortable for customers than the sort of on or off blast of a natural gas or oil furnace. It's net cheaper for the utility. It's good for the grid. It's good for avoiding winter peaks. It seems like a win-win. So just to wrap up, what do you see as the big impediment?
I want to be a little picky on one of those. So it can be cheaper for customers. So that monthly energy bill is expected to be cheaper, and it is in a regulated utility. Of course, that is determined by the rate making and what duration of time we spread out the upfront cost of the infrastructure and how we approach that. So there are a lot of projections, but it does depend on the regulator's decision making, and I just want to qualify that.
Right. So this is a classic clean energy case of high capex upfront.
Yes.
Savings over time.
Yes.
And so you're in the same discussion you are with so many other contexts, which is who provides that upfront money? How expensive is the credit? How patient is the capital?
Yes,
so I guess
exactly.
This is kind of another reason, to do it with the utility is that they have some patient capital.
And maybe to be a little bit optimistic here, but I'm hopeful that we'll see something similar as we have with other clean energy technologies, where unit costs come down as it matures, right? As we scale, as we do more of this, as the workforce develops, if we can continue to drive unit costs down and expand the size of these networks, you get to that unicorn zone where you can pay back the infrastructure and not increase the energy burden on your customers, and they're getting clean, carbon-free heating and cooling. That's the perfect world that you want to get to.
I'm guessing a lot of these customers are going to get cooling for the first time. Is that true?
We didn't get a chance to get into that, but that was a huge selling point as well. You get into the customer's home and say, it's going to be geothermal heating, it's going to be super efficient. Oh, and it provides cooling, so you'll have central air essentially. And they say, sign me up.
Yeah. That's a critical health aspect. And when we talk about what humans actually want and not what energy nerds want, the cooling, the affordability, the quality of heating and cooling, the reliability of the cost of the bill, these are things that matter to everyone.
This is like a win-win. It's got a lot of things going for it. What is your big concern? What keeps you up at night? What do you think is the biggest challenge in spreading this?
For me, it's driving initial costs down. It's figuring out how to do this equitably and responsibly for our customers and really develop a business line that they're happy to sign up for. I mean, if I can get my costs down and I can get those geothermal rates established with our regulators that make sense, I'll be happy. But for now, I think that that's the big challenge.
Mm-hmm.
I think my number one would be knowledge. It's new and there's a lot of terminology confusion. There's a lot of confusion even at the engineering level that can result in unexpected outcomes. And I worry, it keeps me up at night. Most modelers aren't yet taking into account thermal inertia, right? So we're in that risk zone, the Wild West, where there's so much excitement, there's so many projects moving forward, and we don't yet have guidelines, books, articles showing an optimized best path.
Right. It does sound, though, like HEET is really going overboard to just study the living crap out of this thing.
We are trying so hard, David. And we're enjoying it, I'll admit. But yes, we have a working model, a techno-economic model, a reduced order model. We're using the data from the first projects to make that model as real as possible. And we're making it open source for everyone. We've launched a data bank. We've launched a cost survey. We're trying as hard as we can to go as fast as we can on that.
So that materials, to make it more that another utility, the next utility can just take something off the shelf and follow a plan. That's coming. You're working on that.
We're all working on it. There's just so many people trying to make this operational in a reliable way.
And for my part, the beauty of a utility is I can go and share with all of the other utilities and really try to take the lessons we've learned from our first one and pass them along. I mean, utilities are not competing with each other over customers here.
Yeah,
so
that's true.
Anything I can do to share knowledge, lessons learned, here are issues we had, avoid this, try and do this way. I'm taking those calls because frankly, I want everybody to be successful.
Yeah.
Awesome. Well, thanks, you guys. This is so cool. This fits right in with my thermal obsession, my grid balancing obsessions, all my obsessions. And so much stuff is happening. So maybe we'll talk again in a couple of years. We'll have some non-pilots, maybe some actual, take the word pilot off and just have it be a normal thing somewhere. I bet we'll see that in 2 years.
Sounds good.
All right. Thanks, you guys. Thanks for coming on.
Absolutely.
Thank you.
Thank you for listening to Volts. It takes a village to make this podcast work. Shout out especially to my super producer, Kyle McDonald, who makes me and my guests sound smart every week. And it is all supported entirely by listeners like you. So if you value conversations like this, please consider joining our community of paid subscribers at volts.wtf, or leaving a nice review, or telling a friend about Volts, or all three. Thanks so much, and I'll see you next time.